Hello, everyone. My name is Costin Leau. I'm the lead for Spring for Apache Hadoop project. Here with me is my colleague Mark Pollack, who will be trying to answer most of your questions, as Amy mentioned throughout the presentation. We have a dedicated Q&A section towards the end. We'll try to go through as many questions as possible, but if for whatever reason we cannot answer or your question doesn't get answered, please do reach out to us. You'll see we have plenty of links and we're very interested in feedback. So without further ado, let's move on. The agenda for today is pretty straightforward. We're looking at introducing the key features for Spring for Apache Hadoop. We start off by looking at big data and the Hadoop ecosystem. And then I'll look at the key features in the Spring for Apache Hadoop, mainly around core Hadoop. And then sort of take a look at the big pictures, looking at big data pipelines, such as workflow and event streams. Also, we'll wrap everything up with a Q&A. A bit about myself. I've been working at Spring Source for almost 7 years now, since back in the day when it was called Interface 21. I have worked on various projects such as core Spring framework, authored and worked on various features, led the Spring Dynamic modules, and in the last couple of years I've been working around Spring Data, until recently led the Spring Gemfire effort, and currently leading Spring Redis and Spring for Apache Hadoop, which we're going to talk about today. So before talking about Spring and Hadoop, let's put things into perspective because context is always relevant. There are some interesting trends regarding data. One of them is that we have a lot of data around us, approximately or apparently around 1.8 trillion gigabytes split between 500 quadrillion files. We're talking about some big numbers here. And based on the trends in the last decade, we're looking at a growth of apparently 120, 130 every 2 years, which means we're doubling the data, the digital data around us every 2 years, 2 years and a half. Now, if you look throughout the enterprise, the data itself, you have some interesting insights. We're looking here at the U.S. Bureau of Labor Statistics, so obviously this is relevant or specific to U.S. The data is also somewhat old, from 2009, but at least it gives you some perspective. On the left-hand side, you can see the number of petabytes stored inside United States. As you can see, the first one is discrete manufacturing, then followed by the government, and then communication and media. On the middle, we have the number of columns for employees, or at least 1,000 of employees, and then on the right-hand side, we have the number of data stored per employees. Now, if you look there, you'll notice that even though we have a sort of a top 10 of petabytes, when we're looking at the number of data stores per employee, securities and investment services are obviously the higher up there, which is not surprising. It also is sort of the government, communication, and media in the top 5. The bottom line here, what we're looking at is that 15 out of 17 sectors, at least inside the United States, have more data stored than the U.S. Library of Congress, which is approximately 320 terabytes. Some of them actually have a lot more than that. We're looking at petabytes of data. Now, if you break down the data, the actual data stored into content, you'll notice that we have the usual suspects, sort of video, image, audio, right? Data structures that tend to take a lot of space, but also the vast majority are actually storing numbers and text, which is not so surprising actually. And we're looking at unstructured data, right? Because each organization has its own type of information internally, different storages, different sources of data. So there is no predefined model, and not definitely one that fits into a relational database. We have pre-aggregated data usually stored with the raw data. So as the data is being collected, you can have all sort of counters of aggregation being ran, averages, some sort of indices typically. So it's very easy when you look at the data, you have some sort of label, so it's very easy to go through it. Now, on the other hand, we have this trend that's been going on actually for a long time now, 20 to 30 years maybe, where you have this decreasing cost of hardware, meaning every 1 year and a half, 18 months, the hardware cost basically is halved, which means what previously was a big iron as a solution to store a lot of information and go through a lot of information now costs a lot less and can be addressed through commodity hardware, or literally rather than scaling up, you can scale out literally by using a cluster. And this goes hand in hand with the various offerings out there where you have things like cloud computing, where rather than owning your own hardware, you can actually rent out hardware. So what we're looking at is this inflection point where the value from data exceeds the hardware software cost. So why is data relevant? Well, because you have all sort of pieces of information, insights into the source that creates that data. Now, big organizations like Google or Amazon or eBay have been doing this for quite some time. On one hand, because obviously it improves their bottom line, and second of all, because they are a big organization, big IT shops, so they could absorb the cost. But while we're looking in the recent years in this inflection point, where because the software and hardware now are more accessible, you can actually use that even if you are not a big shop, so you don't have to burn up your funding for 1 year or so. You can just rent it or potentially even own the cluster and actually start tapping into data. So throughout the industry, this problem of collecting a lot of data or any relevant data, storing it and analyze it is called big data, right, which supposedly it refers to the size. And since we're talking about numbers throughout the sectors, typically big data solutions range from anything between terabytes, tens of terabytes of data to multiple petabytes, and in some cases a lot more than that. Obviously, big data as a definition, as a solution per se, is somewhat subjective and generic. Obviously, it depends on each organization, what type of data they want to store, what type of sources they have out there. You can think of anything ranging from emails, let's say the PDFs, to metrics about their system, such as the network, number of network packages coming in, the number of users, web hits, anything and everything can be relevant, can be a valuable data source. However, we do see some emerging solutions, some sort of de facto standards out there for dealing with big data. And the de facto solution for big data nowadays is Hadoop. It's a JVM-based solution that handles, first of all, the low-level infrastructure. You can see here on this slide, there's two green boxes at the bottom. The first one is the distributed file system that gives you the ability to just use Hadoop to create this distributed file system across your clusters. So you only have to put in machines. You don't have to worry about what happens. How can the software deal? How can my cluster deal with machines coming out, potentially getting out, or potentially being killed, right? We're talking here about a lot of data that doesn't fit into one machine, so we have to distribute that across. And obviously, as we add in more machines, so does the rate of failure. With Hadoop, you don't have to worry about that one. You have the infrastructure in place. So as a developer, as a user, you get access to this file system, generic file system that you can just use and then store data in. Now that you have data, and a lot of it, obviously you need to go through it, so you need a lot of computational power. And again, you don't really want to compute all this data with one machine because it's going to take a long time. So with Hadoop, you also have this framework, the MapReduce framework, that gives you the ability to just write code, and the code gets dispatched into the cluster and ran across multiple machines. Because MapReduce and Hadoop in general tends to be fairly low level, you have various libraries out there to provide a better abstraction, or at least for certain use cases, to adapt to certain users. I've mentioned here on this slide the biggest or the most popular libraries out there. We have Cascading, Pig, and Hive, mainly for doing queries. But you also have things like HBase, which is a data store which provides near real-time queries on top of HDFS. You also have the guy there on the left-hand side, which is basically a bazooka Zookeeper, a service that is used internally typically by Hadoop and Hadoop-related services to manage the entire cluster. I usually refer to him, I put in him because indeed when you're looking at a cluster, you end up to have a zoo, and what better solution to that than a Zookeeper? So where does Spring for Apache Hadoop come in this scenario? So first of all, if you look at the project itself, Spring for Apache Hadoop ties into the Hadoop sort of nature of problem. However, we're not reinventing everything. We're actually leveraging, as you'll see, a lot of the functionality that's already out there. We built on existing service abstractions. So we integrate a lot with Spring Frameworks itself, the core framework. We use it a lot for doing configuration, injection, wiring, and also using things like property placeholder for externalization. It's not something that we use directly, but it's something that you, as a user, as a developer, can use with Hadoop. It works very nice. Since Hadoop typically is not an island, actually it's part of your system because you need to get data from your system to Hadoop and then do some sort of analysis and then push it out. So we're talking here about some sort of workflow. As the data goes in, typically you want to do some sort of analysis, you want to get the results out, and these typically are stored somewhere else in some sort of faster access storage. And this is where Spring Data comes in, offering a lot of support for things from JPA relational database stores to non-SQL data stores such as Redis, MongoDB, Neo4j, GFR, and so on. Hadoop is primarily a batch system. You end up with a lot of jobs that potentially take anywhere from 30 seconds to, let's say, days. And typically you want to chain them. You want to create some sort of workflow where you go through the workload step by step. And a great solution there inside the Java space is Spring Batch. We integrate deeply with it, AOC, and it's an excellent solution if you want to do on and off Hadoop workflows. And also, since we're talking about integration, especially when we're looking at different data sources and event-driven application, Spring integration is a solution that we integrate with as well. So in terms of project goals, it's fairly simple. We aim to simplify developing Hadoop applications. As I mentioned, Hadoop is a failed infrastructure service. It is a low-level programming model, which out of the box gives you a pretty poor experience. A lot of things revolve around scripts, executing scripts from the command line, and you end up with some sort of spaghetti application, which is kind of hard to maintain and develop. So we're trying to address that piece of the problem by offering a familiar and consistent programming model and configuration model using sensible defaults. We're addressing a wide range of use cases, whether we're talking about the actual job types to do some sort of analysis ranging from raw or vanilla MapReduce, Pig, Hive, Cascading, to HBase, to creating a bigger constructs such as workflow, to low-level integration with HDFS, interaction, doing cleanup, things like that. Basically, it's about allowing you to start very fast, start small, and organically grow without having to think too much about it when you start your app, you start development. So capability-wise, at least in this version, we have sort of two major features, if you like, or two major camps. One is declarative configuration, meaning very easily, without having to write any code, express what you want to happen. Literally wire things up without having to learn APIs, without having to deal with Java code. And even better, make that available as you move between different environments, because you will run your code as a developer locally or potentially against a small cluster, and then potentially go through production. So you want to minimize the number of changes because things here take a long time, potentially have a high cost associated with it. So the less changes, the better, right? Because you have less breakage appearing into your app. And also we're looking at developer productivity. And here again is about creating well-formed applications, trying to get rid of the spaghetti scripting, making things cohesive, simplifying the various APIs, as you'll see, and providing a idiomatic, if you want, APIs that make it very easy to use one-liners to focus on the type of code that you have to do, not necessarily on doing resource management, especially as these different libraries between Pig, Hive, HBase, and MapReduce as well tend to throw a lot of exceptions, tend to, due to the nature of Hadoop itself, expose that sort of infrastructure or low-level detail up to you, to the developer. In terms of resources, the link at the top is sort of our homepage. It's really easy to look and find once you hit our SpringSource.org homepage. And even though we're a fairly young project, we had our first RC last month around the Spring 1.2GX conference. We're aiming to have a GA, or we plan to have a GA for December, early December. We have a lot of samples out there, a lot of documentation to go through. On the sample side, we also have official samples, Spring Hadoop samples, but also we have a book. It has been already published called Spring Data. All the authors are actually part of the Spring Data team, so they really know what they're talking about. It has a dedicated chapter on big data and Hadoop and all the other technologies inside the Spring Data stack, such as key value store, integration with Redis, with Gianfranco, Neo4j, and so on and so forth. And actually, one of the authors, Mark Pollack, is here helping me with the questions. And for what it's worth, all of the proceedings from this book are going to the Creative Commons Foundation. On this presentation, I'll show sort of mixed samples from both sort of Spring Hadoop, or the official samples, which are up to the point and easy to pick up. But I'm going also to show some samples from the book. Again, all of the samples are available on our GitHub account. The samples from the book are have a lot more depth to it, if you want, and obviously a lot of more documentation associated with it in the form of the book. So let's take a look at the feature set. So what better way to get started than with the hello world, which in case of Hadoop is counting words. The hello world sort of for doing parallel computation, in this case counting words. I'm showing here the actual code taken from the Hadoop word count example. I've tried to fit it up into the slide. As you can see, there's a lot of text, and I tried to gray out the irrelevant areas. These are basically the interfaces or classes that you have to extend from the Hadoop MapReduce API, doing small setup, and actually getting down to the business, which in this case would be inside the mapper to just tokenize the lines of text that are coming in, split them into words, send them to the reducer, and then the reducer do the actual counting of words. Obviously, there are some things here. I'm not going to drill deep into this, such as why are things like that? Why can I just do the whole work inside the mapper, or why I just blindly send keys to the reducer? And that has to do with the way the MapReduce contract works, which is the keys get sent in order to the same reducer, things like that. But as you can tell, while the code is somewhat intuitive, I mean, I can guess what's going on, the semantics of it tend to be pretty low level. Once you potentially have the MapReduce job in place, you have the actual code that does the whole work. Again, per the official documentation example, you have to configure this code. So this configuration ends up by being some sort of setup written in Java, where you literally say, okay, these are my classes, create some configuration for it. This is, again, the things, the statements in black are the stuff that you actually want to focus on, which is create a configuration. Here is the output, here is the input, here is the output for my job. This is where I'm reading, and this is where I'm writing, and that's it. Submit the job to the cluster potentially. But again, as you can see, you have some boilerplate code where you have to specify the classes, potentially the input and output format, the key and value classes, things like that. Once you have these classes arranged, you typically put them into a jar, and then you ship them out. So this is the first example where you can see a Spring Hadoop feature. Now, typically with vanilla Hadoop, once you have the jar, in this case the Hadoop examples, because I've used the word count example, you would just have the jar run from the command line Hadoop jar, specify the jar, the input in this case word count, input output, and then run it. With Spring for Apache Hadoop, you can take the same jar and then import it into your application. We have there the HTTP, that's a prefix from Spring Hadoop dedicated namespace. And you can see there are two elements. The first one is the configuration. This usually says create the default Hadoop configuration. So it's going to look at the common location, figure out the defaults, is going to use that, and then run jar runner, which is run this jar for me. So literally is going to take a look at your jar, is going to pass in the arguments, and then is going to detect the job from it, and is going to submit that, right? So we literally have the same jar where you configure the MapReduce and the configuration, put it inside a jar. We can work with that automatically out of the box. Except that, as you can see right now, you have full control over this. You don't have to go through the command line. You can embed this into your application. You can also use what Hadoop documentation calls WordCount 2.0. This basically is a minor improvement to the first example in which you're using what is called the tool interface. So rather than sort of just doing yourself the configuration, as you saw initially, we actually created the new config object, the new configuration object. You can choose to have Hadoop create that for you based on some parameter or some configuration file, and then put that, ship that to your application, so the application can actually use that in order to do the configuration and then submit your jobs. The workflow for vanilla Hadoop is the same. You have bin Hadoop, the command line, start jar, point up to your, again, your jar. You have specify the word count, the input and the output, and then you specify the parameters. Now, with Spring for Apache Hadoop, again, we can take the same workflow and put it here. Notice how for the configuration element, we can allow the configuration to be overridden. So you can specify different properties. You can even specify the properties inline. And we have, again, for tool support, the tool runner namespace. Similar usage. You can probably see here that in this case I don't specify necessarily the org, my org word count, and that is because as much as possible we're trying to look at sensible defaults. So you have specified a jar already. We know this is about tools, so we're looking at the jar. We know, look at the classes, figure out the main entry class. We know that's a tool, so we can automatically do the injection here between Hadoop configuration, right? Because this is a Hadoop application. You have created a configuration, and now you're trying to run a tool. So obviously that tool needs to be run against a Hadoop cluster. We automatically do the wiring, so you don't have to specify, we automatically do the detection. Now, all of these things can be specified if you want to, and can be overridden, can be customized. It's entirely up to you. It's just that we try to take care of the little things, so you have to just focus on the actual work without having to bump into all these small things. Talking about configuring Hadoop, we have a rich support for that. Here I'm just showing, rather than potentially creating the job configuration and embedding that into a jar, which is perfectly fine, we're configuring the job directly. So actually in your jar, you only need the job. You don't need to embed the job configuration with it. You can externalize it. And obviously the benefit here is that you can reuse the same jar all over the place, and the entire configuration for the job fits in your application, right? Which makes more sense because it's closer to what you want it to do. You don't have to embed it and keep copying the same jar over and over again just because you have some minor configuration differences. So as you can see, for direct job creation or job configuration, we have the job namespace, specifying the input path, output path, the jar, and then only the mapper reducer. Now, this as well are optional. If you don't specify, we're going to use the default mapper reducer, such as identity mapper. But also, you don't have to specify the output format or the input format, the key or the value classes. Again, you can if you want, but you don't have to, because again, we're doing introspection here. You give us the jar, you give us the classes, so we're going to look at them and figure out the signature, the class signature, potentially any generics that are in place, and going to use that in order to fill up the job configuration for you. Notice that in this case, I'm configuring the job, and then I'm specifying a job runner, which means I'm creating the job object itself, and then I'm choosing also to run it. But these two things are separate. I don't have necessarily to do that as I do with Hadoop, meaning I can create a job, and then later on I can use that object. Also notice that I'm not hard-coding the path anymore, the input and the output path. I'm using what we call these property placeholders. So I'm using, in this case, just piggybacking on the property placeholder support from Spring Framework, which literally says this placeholders, input path, output path. In this case, for my default configuration, I'm overriding the Hadoop file system location. Rather than having these values specified here in line into my application, I can externalize them. So they are read from this Hadoop dev properties, and the runtime when my application starts, actually the placeholder are replaced with the actual values. Right? And obviously the idea here is my application remains the same, my configuration remains the same, and I only have to deal with this environment-specific options in a separate files, so I don't have to deal with it right away. I don't have to modify my application. In terms of streaming jobs, we support that as well. At the top, you can see the vanilla Hadoop usage. Again, I'm running the command line. In this case, I'm using Hadoop streaming jar. I have to specify this jar, and then I'm specifying the input and the output, the actual command. In this case, cat and WordCount, and potentially some files I want to be wrapped with the actual jar. Again, we have first-class support for that through the streaming namespace. We automatically handle, we know that this is streaming, so we can take care of the jar packaging. Again, we provide sensible defaults, and we're trying to do any filling as much as possible there. Notice that, again, we support, for example, as we do with files, Spring Resource Loader, so you can load things not necessarily from the file disk. You can actually load things from the file path or any type of environment where you do have like HTTP, any type of URL, because we're really just relying on Spring Resource Loader. Again, we're using properties placeholder here, but actually we're doing a bit of a spin. In this case, notice that, again, we're using Spring, in this case, Spring 3.0 properties placeholder alongside the environment abstraction. So rather than just externalizing things outside, we can also say, well, as I'm moving through different environments, I like to not necessarily change this file, but have different files. One configuration which sits for my development, and one configuration potentially that sits that's available for QA. So now my application is the same. With property placeholder, my configuration is the same, and also with the environment abstraction, my entire application, the configuration itself, and the application remains the same. So in this case, you can see, for just an example, as I'm using for this particular example, the command line environment, in this case env, to switch between Q&A and development, and literally tell Spring which file to look at when it does property placeholder. So I can use in development my local single node MapReduce cluster, and then as I'm going through Q&A or particularly production, I don't have to change anything. Again, less breakage, less changes, less bugs. So far, we've looked at what it takes to sort of run existing, to use the existing Hadoop workflow. So typically you would use things from the command line, and obviously you would have jars. Spring for Apache Hadoop supports that, so if you have any jars available, whether using tool interface, whether you're using your own configuration, we support that as it is, or streaming. You don't have to do any configuration. We automatically figure that in, and again, do the wiring with Hadoop configuration. But one interesting thing here is that Spring for Apache Hadoop doesn't have to work necessarily that way. Right? If you have a job, doesn't necessarily mean that when you declare it, when you use it, you have to automatically submit it to the job, to the cluster. So what we're doing here is, rather than saying this is a job and run it, we can say this is a job, this is a configuration, and it's up to me to decide where I'm running it. Right? Because these are just, as far as Spring is concerned, just job objects. They are just POJOs. So here I'm just injecting this job, and then it's up to me to submit, to trigger the job submission on demand. So I can deal with that. I can do scheduling, as you'll see, and all sort of things, especially when we're dealing with counters or things like that. I've mentioned that we also looked at what it takes in a workflow to handle HDFS. Now, typically, whenever you run a job, you need to do some sort of validation or sanitization of the data that comes into your job or goes out, such as is the output folder already there? If it is, then probably I have to move it, create a different folder, or is the data that I have to look at already there? Anything, other permissions, okay. So typically, you have to interact with the HDFS. Now, you have a solution for that in Hadoop, again, a command line called a Hadoop file system shell. What we've done in Spring for Apache Hadoop is promote that as an actual API. So you as a developer don't have to run things from the command line. You can get full access to it as an API from within your development environment. So all the commands that you know and use, like make directory change, permissions, test, all those are exposed through the FS shell. It's just an API that mimics as much as possible and uses the same semantics as the actual file system shell. So now you can actually use, for example, in Java, I can have this initialization class that actually just has the shell injected, and then during its initialization method is going to do this basic, for this case, work where it's going to check out whether the folder is there, and if it is, going to remove it. However, for scripting, really what you want to do is use a scripting language. It's more appropriate. And in the JVM realm, we have plenty of support for that, right? Whether we're talking about Groovy in this example, Ruby, Python, or JavaScript, right? For all of this, we already have translations that, for the most part, allow you to use a native Ruby script, for example, to run in JRuby, same for Python with Jython, and with JavaScript with Rhino, which is actually even provided for you out of the box inside the JDK. So here, I've just sort of expanded the previous script in Groovy. So here I am doing something more like testing the input directory. If it's not there, I'm going to copy, just for the sake of the argument here, a local file, then set some permissions, and then also check out the output directory, right? This is just a development environment. I don't really care about saving the output. I just want to make sure that my job runs fine. So the script is here, but how exactly can I use it? Right? Well, again, this is about making things easier for you. So you can use this in a declarative fashion. This is exactly the same script, and actually, if you notice, I just use the Spring for Apache Hadoop script namespace, which allows you to specify any GSR 223 scripting language and make that available for you inside a Hadoop environment, which means, first off, that because it's a scripting language, it gets executed when you want to. You can bind any variable that you want. So in this case, I'm using, again, input, output, there, source file, and notice, again, I'm referring for the actual value as a properties placeholder. But also that because it runs inside a Hadoop environment, I already have the Hadoop, in this case for the shell, the file system shell, made available to me. So this is all I have to do, and then potentially declare a Hadoop configuration, which means Spring for Apache Hadoop is going to read the configuration, is going to connect to the cluster, is going to automatically create a file system shell for me, is going to make that available as an implied variable to my script. So now I can just execute my script without having to worry, how do I connect to Hadoop? What do I do with the shell afterward? Do I close it? All this is taken care of for you. Now, again, this is just an example. So here you can bind any variable that you want, right? You can actually bind objects. You can use Spring to create objects and then make them available. So you can share them, or you can create one per script. It's entirely up to you. In terms of library support, again, we have a first-class support for the various suspects out there. So, for example, when we're looking here at pig, which, right, it's a good candidate. This is, since we talked about counting words, how things will look like in pig. As you'll notice, again, I've tried to use sort of the same convention, graying out as things that are not relevant and just focus on the stuff that's really is useful. So what we're doing here is, rather than writing code, we're using a declarative approach. Right? We're using this sort of scripting language where we literally chop data as it flows in. So I'm loading things from a file system, doing some tokenizing, then I'm doing some filtering, literally splitting out through a regular expression the various words, and then doing a group by, and then for each group I'm going to do the counting. So it's somewhat resembles, if you want, SQL. It's not really SQL, but you can see this idea of various actions or verbs that I can use in order to apply actions on my data. Right? Obviously, it's a bit more easier to comprehend, I guess, that raw MapReduce. You don't have to focus so much on the semantics. Right? It's a data flow language. If the data flows in, I'm applying various actions to it. Now, in terms of usage, now that I have my script, I can use vanilla pig, which, again, just like Hadoop, is command line focused. So you have a pig command. It's sort of a shell where you can specify your script and potentially pass any parameters that you want, potentially for a script or potentially to configure a pig, depending on whatever settings you want. Now, with Spring for Apache Hadoop, again, just like with a raw Hadoop, and again, this is the consistency theme that we're looking here, you can do things in a declarative approach and you don't have to do it from the command line, right? So you can declare what is called a pig factory that creates a sort of a connection to pig server. Right? This is where you configure pig, and then all your scripts can run against this pig server. Obviously, you can have multiple pig configurations depending on whatever settings you want to, different properties, different configuration, potentially different priorities. And as well, you can execute a script at startup. That's basically one for every pig instance. So here we can do things like registering user-defined functions or other things of that sort. So now that we have our script, how do we execute this against pig? So here you can see a workflow. The first line there is just a one line to say, okay, this is a pig factory, right, and specifying some properties. Obviously, we support defaults, but in this case, we're just showing that you can customize it if you want. You can specify properties in line, or you can just read properties. And then I have the pig runner there at the bottom, which again, it's a runner where I'm specifying, well, run a startup, so when my application starts up, execute this script. Notice again how we relying on defaults. In my pig runner, I don't have to specify the pig factory, right? Because we know this is a runner for pig scripts, and we know you have already declared a pig factory, so obviously these two go together. So again, we're relying on this default wiring. This is something that's pretty much documented, and you'll see throughout all components or all job types. But again, this is something that you have full control over, so you can customize it and potentially wire to a different pig factory if you want. So what we're doing here is specifying the pig location, word count pig location, specifying the arguments. But what's interesting there is the HDFS script. If you've noticed, my pig runner has this thing called pre-action. So for each runner, we support what is called a pre and post action, which allows you to literally call different runners or different callables throughout your definition. So what I'm doing here is actually creating a simple workflow so what I'm doing is saying, well, execute this pig runner, this pig script as startup, but first off, call this runner, which in this case is a script. So I'm executing, first of all, the copy files Groovy script. In this case, I'm referring to it. Notice that compared to the previous definition, I don't have to specify the language, because in this case, you have specified already in the extension of your file. So I'm loading that, doing the binding of the variable source file input and output directory using the property placeholder. The shell is already available to me. I don't have to bind that. That's an implied thing, right? Because this is the not just any script, but a script running on top of Hadoop. And after this script, this Groovy script gets executed, then I execute my pig runner. And obviously, you can chain them. I can use a pre-action, and then I can use also post-action. Now, another interesting thing of a feature of pig runner, or runners in general, are all of them are callable. Implement the JDK callable interface. So you can run them, you can inject them as a callable, and then you can run them whenever you want. So there at the bottom, you see an example where I'm creating my pig runner. I don't necessarily have to run this pig as startup. I can just create it and say, well, this is a runner, basically, that executes this particular pig script, WordCount.pig. So in my code, I can say, well, whenever the schedule, in this case, again, I'm using a Spring 3.0 feature, which is the at schedule annotation. Whenever there is midnight, that's a cron tab expression there, my method, in this case, process, is being called. So I can do whatever I want in this method. So this particular case, I'm just choosing to call the pig runner's bean definition or the pig runner object, but obviously I can do a lot more. I cannot just run a job. I can potentially do some sort of things to the database and then run the pig runner. So you can see this mixture of Spring for Apache Hadoop features, but also other features from the rest of the Spring projects, framework, and as you'll see, batch and integration as well. In terms of usage, we also have, for those that don't want or cannot use the declarative approach for executing scripts, we also have for a programmatic approach the pig template. Now, if you're familiar with the template pattern or have used Spring, you probably know where I'm heading with this one. This is just a class that takes care of the boilerplate code. So it acts as a template, if you want, for common operations. So the boilerplate code gets eliminated and you can focus on what's really important. This is just how the configuration looks like. Notice that I'm using the pig factory, declaring a one-liner for pig template, This is one example where I want to specify the pig factory. Again, if I don't do that, it's going to just apply the defaults. So what I'm using here is a bean definition. This is a class code that I'm using for a Spring Data book. It's called pig password repository. Again, you can find all this along with many other examples in our GitHub repository, where I'm literally using this pig factory, so a big template. So what I'm doing here is literally saying, well, I want to execute things. I want to execute this pig script for this input file. So this is something that I have to work with programmatically. This is not something I know up front, so I cannot just have a declaration for it. So just for the sake of the argument, you can see how things look like. This is just a starter class. I'm just injecting a pig template, and I have there the pig script that I want to run. Notice again how I'm using the resource location. I'm referring to a pig script from the class path. This is again quite convenient, especially as you move between developments, because you don't necessarily have that pig script locally on your machine. Now, if you want, obviously you can refer to a pig script from within HDFS. We support that as well, especially when you combine it with the distributed cache. And now in my method, all I'm doing is, well, setting up the script, the parameters, and then running pig template execute script. That's it. I don't have to worry about where do I get the pig instance, right? Pig server instance, which by the way is not thread safe, which means every time I call one, I need a new instance because I cannot reuse it. I have to basically create one, use it, and then discard it. I don't have to worry about locating the script, setting out the script and the parameters in a format, the native format of pig, handling with the exceptions. And there are plenty of it, some that come from the MapReduce framework, Hadoop framework itself, and some that come from my script, such as the syntax is being wrong. Some of them are actually even checked exceptions, but again, the template here handles all that infrastructure for me and also does the exception translation to Spring runtime data access exception. So I have something meaningful there, an exception hierarchy that is portable and understandable, that gives me something with it. So if I want to handle the exceptions, I can do that. I know whether I have a syntax error, where I can retry whether the store itself went down for whatever reason. I don't have to learn the whole exception API. So I can just execute scripts without worrying too much about the infrastructure. Now, Hive is another popular library out there. This is, again, sort of an example of what counting words will look like. You'll notice that maybe it's the shortest example from the entire word count, but actually there is some hidden complexity in there. What I'm doing here is just creating a table. As you notice, Hive is more SQL-like. It actually has a Hive query language, which is somewhat similar but not identical to SQL. So I'm creating this idea of a table. You can think of it as some sort of view if you want. And then I'm importing data into it. And then I'm doing the select, and this is where things get tricky. I'm doing actually saying, well, select the word and do a count for the words, but actually this is where all the action happens. I'm doing this lateral view, which really is going to, as it looks at the table, is going to, on the fly for each column, is going to create this operation, which is literally get all the columns, then for each, in this case I only have one, for each line, for every row, is going to do a split, basically remove the spaces, and then you end up with the words, and then these are grouped by, and then I'm doing the actual counting. So resembles SQL, but it's not really SQL, and definitely doesn't execute in the same amount of time. Everything here that we're showing actually gets translated at some point into MapReduce jobs, and you're not really sure, especially with when you're doing things like this, of how fast these are going to be executed. Now, once that you have your script, if you want to execute it, again, you're looking at the command line. You have the Hive command, you specify your script, again, potentially specify where your Hive server is. This is how it typically works for Hive. You have a server somewhere that you execute queries against, and potentially some parameters. This is the command line approach, but also you have a JDBC API. Because Hive resembles SQL, you can use JDBC on top of it. So what I'm showing here is actual code, again, taken from the documentation, and this is just raw JDBC. There's nothing Hive-specific about it, except maybe the driver class name there and the URL. Everything else is just pure JDBC, right? Which, again, it's a low-level API, so you have a lot of exceptions, a lot of boilerplate code that you have to go through. Get the connection, create a statement, prepare the statement, execute the query, get the results back, look through it, and at any point in time here, you can get a SQL exception, which is quite cryptic, meaning you don't actually get an exception by name, but you get an exception, then you have to look at the code, and you have to figure out what that code maps to, and then figure out what the cause of the problem is. Did I made a mistake in the SQL that I'm writing? Did I do anything else? Is the data there? Maybe, again, the data store went down. Is it something that I can recover from or not? You have to look at the codes and do cleanup. So if you're looking at the JDBC approach, which is quite tempting for most people because, again, it uses some knowledge that you already know, you can use just really the support that's available inside Spring. You can just use a JDBC driver for Hive. Again, this is part of the Hadoop package. And then you can use in Spring Framework the simple driver data source. This is just a wrapper to expose the driver as a data source, specify the URL, potentially use the property placeholder for externalization. And then you can just use the JDBC template. It's well known. We used pretty much everywhere. Has plenty of features, including this from anything ranging from one-liners like query for long, I'm just doing the query there, or if I want to have more mapping, I can do this, what is called lightweight mapping, when I'm taking back the result set and then doing the mapping. Notice that, again, with the template, I don't have to deal with opening a connection, closing it down, catching exception, closing down the exception in case something went wrong. Everything is taken care of for me, especially when I'm dealing with SQL exception, which is a catched exception. Now, if you're looking at the command line, what you can deal with here is if you don't want to use a command line, as a developer, you can use the Thrift API. So basically, rather than writing things from the command line, you have a Thrift API, which is based obviously on the Thrift protocol. This is just a RPC mechanism where you can do remote invocations. This is, again, code taken from their docs, and what we're looking at is what it takes to do that select count. So notice how I have to create a client. Again, Thrift clients are not thread safe, just like pig. So for every invocation, you have to create one, do your actual work, and then close it, which means not only you have to do this tiptoeing around the actual creation, but every component that interacts with Hive has to be aware of this lifecycle, and moreover, has to have its configuration, the Hive configuration there, so it can create new objects. And obviously, this is a leak concern. Notice that we have a lot of checked exception. I think in case of Thrift, things get really ugly because you have a lot of exceptions. All of them are checked, and none of them, for the most part, share any common parent. So you really end up checking and catching any checked exception out there. Now, with Spring for Apache Hadoop, we simplified a lot of that. We give you a nice declarative configuration, so you can just create this client factory. You specify the port and the host, and that's it. We automatically take care of creating a new instance every time you need one. You can use a Hive template. We have that. I'll just show that in a moment. But also, what's interesting, we allow you to create an embedded Hive server. So typically, you would have this Hive running as server running as a service on a remote machine, and then you start it up, run your application, then potentially close it down. However, we do support starting the Hive server automatically with your application. So this is great for testing. We use it a lot, meaning that you can just put in your Hive server, your application starts, so does the server run your application, potentially shut it down. Again, great use for testing. In terms of declarative usage, now that you have Hive configured, again, we have a Hive runner, already know what it does. You can set it to run a startup, have pre-post actions. You can declare, just like with Pig, scripts in there, nested, literally you can just inline them, or you can refer to other scripts and use a location, and again, specify any parameters. For programmatic usage, we have the Hive template. Just like the rest of the templates, again, this is about having familiar concepts and patterns wherever technology you use, whenever they apply. Allows you to have one-liners for doing queries. So here, again, taken from the Spring Data book, I have a Hive template password repository. I'm doing more of the same thing. Notice how I injected the Hive template, and then I'm just executing the query for long. You can also notice I'm using the add value annotation. This comes from Spring Framework to externalize, to allow injection, annotation-based injection, which actually uses externalized values from properties placeholders. And again, I cannot just execute queries, but I can also execute scripts through the query API. And again, the whole problem of dealing with the various checked exceptions, looking at the error codes, figure out whether they are server code, client codes, things like that, already happens. It's already covered by the Hive template, so you only have to know if you want to about data access exception hierarchy, which is portable across JDBC, Pig, Hive, and HBase, as you'll see in a moment. Now, Cascading is another popular library. The previous two, in this case Hive and Pig, are declarative language, offer a SQL and data flow language. In this case, you're looking at more of action that you want to perform. So in terms of Cascading, you have this data going in between your tabs, and you apply actions to it. It's a tuple-based, if you want, mechanism. So here I've used, again, the same idea. I try to gray out the things are irrelevant and then focused on the actual action happening, which is, in this case, when we're looking at counting words, applying a regular expression, figuring out the words, and then doing this each. So for each line that measures my regular expression, the regular expression is going to break down the line into words. I'm going to do a group by for the word and then count each group. And then for every group or for every count, I'm going to actually push that out to the tab. So currently, so far, we've used and I've displayed XML configuration. And while some people might frown upon it, and I get that, it works great with Hive and Pig because it's a declarative language. It's great for describing data, right? It's extended metadata language. Now, in case of Cascading, because the configuration is in Java, you can actually use Spring Versatility. In this case, use the type-safe configuration, Java-based configuration option in order to declare a configuration. So what we're doing here is I can break down my cascading flow depending on how I want to group them. So for example, rather than writing things by hand in XML, which potentially can be very verbose, I can create my own configuration. So what we're doing here is, again, creating these two pipes that you've seen previously. So I can have my pipe that creates this regular expression generator that does each in the group and have that as one piece of the pipe, and then also wire that in to the second method there, count pipe, where I'm doing the actual counting and then doing for every counting for every aggregator that I created, push that out to the tab. So what I'm literally doing here in this class cascading configuration is creating two beans, count pipe and group by pipe, which are not just method, right? They're beans. That's why I have the add bean annotation in there. So again, this is a function that's available inside Spring Framework. It's just something that you can use in this case to work with cascading. So you can have the entire cascading code there, but the actual Hadoop configuration, you can externalize that. So just for the sake of the argument here, I've shown that you can mix and match that with XML. So I'm using the cascading config there, importing as a bean. Now the container knows that these are actually a configuration class which creates two beans, wire that into a Hadoop flow factory bean. This is something I provide in Spring for Apache Hadoop. And all this is wired automatically with the Hadoop configuration. Again, you can override that if you want. Now, the last technology there that I'd like to talk about in this presentation that we have first-class support is HBase. In terms of HBase, we support the configuration bit, such as which offers a bit more than the Hadoop configuration, and again, we have a dedicated namespace for that, but also we have an HBase template. And this is what most people will look at, because in case of HBase, we're looking at the data store. So typically, you want to put data in and get data out. And again, just like with the other templates, we have the usual suspects. We do resource management, we do introspection, trying to figure out what's going on. You can have one-liners, or you can use some sort of mappers, just like with the JDBC template. It's the same pattern. But something that we do on top of that is we're keeping track of H tables. Now, H tables are literally what you can call your session to HBase, the backing HBase, and there is no, again, just like any other session or unit of work, they are not shareable, they're not thread safe. So what we do here is, rather than just keep on open a new H table every single time, we're trying to figure out whether there's any H table bound to the thread. We provide support for that as well. So typically, in a workflow, you would just bind a H table when your sort of method chaining invocation starts, and then all the methods called on that particular thread are going to use the same H table, so you don't have to create one. And then at the end of that call, that big chain, the H table is going to be closed down. Now, this is something that actually a lot of other templates like Hive template offer as well. So again, it's about providing the same functionality wherever possible, wherever it applies to other data source technologies as well. Now, if you look at the big picture, again, as I mentioned, Hadoop itself is not an island. You typically have to get data in and get data out. And if you come back to our relationship to the other project, I've mentioned that we have a tight integration with Spring Batch and also Spring integration. So Hadoop per se, as data flows in and data flows out, tends to resemble a classical integration workflow. That is, you have these steps that you have to deal with in which you can break down your processes pretty much for all of them. And that is this, what we call 7 steps, where you collect data, potentially do some sort of transformation. As the data goes to your actual store, you can do some near real-time analysis, just to understand what's going on. Typically, this is towards a moving window. And then once the data is there, you can use Hadoop to do the actual batch analysis. And once you have the results, you can distribute them, potentially store the indices in the various stores, such as key value stores, things like that, and then use it. With Spring integration, when you're looking at, obviously, enterprise integration patterns, Spring integration is a solution for that, and can apply actually quite nicely to several steps here. You can use it in do the collection to a single or multiple nodes. You can do transformation with it, either through Java or scripting. For real-time analysis, obviously you can code your own, but typically there are other engines that are better at that, so you can store counters in Redis or MongoDB, as I mentioned. You can use continuous queries, or whenever you're dealing with huge amounts of data, when you want low latency, and typically you would hear a in-memory data query, such as Gemfire, or you can even use a full-blown complex event processing engine, such as Asper, just to name a few. And you can use Spring integration to route things there, potentially do transformation, because again, we're looking at the different data formats there. The ingestion, again, is supported by Spring integration. We have support for HDFS, and also to do some sort of splitting and filtering as the data goes through. And for all of that, you have JMX support. And again, you can use that as well as the receiving end there when you do the distribution. That's typically up to you whether you want to send that to data stores or not. These are just an example that I'm going to spend too much time of it, where Spring integration works fine, and you see why I'm not going to spend too much time. You have a pulling log example, quite common. Looking at a directory, you read the files, and they're being rolled over, and then you push them out, and then once they're in HDFS, you can decide whether to trigger based on the time or potentially the quantity. And with a framework like Spring integration, you can just reuse the building blocks. So just like with the Lego game, you can just take the pieces and then just assemble your line. And the nice thing there is that you can readjust some of the pieces without having to break your entire workflow. And this works nicely because you use Spring integration adapters or functionality available all over the box, and you can use Spring for Apache Hadoop to plug in Hadoop, which is just, if you want, another actor in the line. You have also great support for Spring integration, such as routing things from Syslog D to HDFS. This is if you want the same scenario as before, but rather than using a pull here, you can, let's say, use a push approach, and just for the sake of the argument, you can just reroute things. And if you want to scale out, you can also use a multi-node example where you have multiple nodes creating data that all gets pushed here. All these things are building blocks. All these building blocks that I'm showing are things that are available inside Spring integration. Talking about batch, obviously, Hadoop is also is a batch system, so typically you have a lot of data going in and a lot of data going out. And if you're looking at the same steps, Spring Batch is an excellent solution because it has excellent support for collection, also for transformation. You have a lot of data, so batching is really not so sexy, but it's something that a lot of people have to go through. Right? It's the same repetitive item, but it's really nice to have a framework that understands the different formats, that can do retries, that can ignore an exception if it occurs for the first time, and so you don't have to waste one entire day of uploading a file just because the connection there dropped for 5 seconds, right? So it's a bit more when you're looking at this vast amount of data than just a do while. It's something more than that. You need some sort of infrastructure, and Spring Batch gives you that. There's no real support in Spring Batch for real-time analysis because this is batching. It's not real-time, right? But again, for ingesting and analysis, especially the rich support, actually, as you'll see, you can use Spring Batch with Hadoop to orchestrate your various jobs. So you can use Hadoop to pull in data, to execute data, and then use Spring Batch as a coordinator, as an orchestrator for that as well. And this is just an example on what we call on Hadoop workflows, which means everything is executed inside Hadoop. Obviously, you can have off Hadoop workflows, which is using a different systems to read data from Hadoop, from HDFS, but you're not using the cluster per se to do the analysis. And this is your typical job here, where I'm doing some things in HDFS, then I'm executing a pig script, then in parallel, I'm executing a MapReduce script and a Hive script, and then pushing everything out to HDFS and potentially taking that out. So there's nothing here specific, frankly, about Hadoop. The tasks themselves are Hadoop specific, but this is just a workflow as far as Spring Batch is concerned. And this is how things will look like. This is actual taking from our application. On the left-hand side, you see the how this flow would look like in SDS. As I mentioned previously, with the Spring integration, the boxes there are taken from the integration of Spring integration inside SDS, which stands for Spring Source Tool Suite. And here you can see, first of all, visualize how things look like on the left-hand side, and on the right-hand side, you can see the actual workflow. And again, there is nothing really specific. This is just a job. You can see there are some steps that are being changed, and that's about it. So this is all Spring Batch. You can do this right now with any type of batch support, and you'll see Spring Batch supports plenty of systems, from file systems to relational databases and so on. But what's interesting in case of Hadoop, that on this workflow, I can say, well, this is a job, but this job itself, this workflow, is actually made up of various components that run on top of Hadoop. So this is where Spring for Apache Hadoop comes in. All the things that we talked about, such as executing jobs, executing pig scripts, running scripts on top of HDFS. All this are exposed as first-class citizens to Spring Batch through what is called, in Spring Batch terminology, a tasklet, which is the smallest unit of work inside Spring Batch. So now the batch job is going to execute at every single time this job that are actually executed inside a cluster. And I can do the entire orchestration here. I don't have to run any script. I can then import them if I want to, as I'm doing with import tasklet. I can customize them, but I don't have to do the orchestration myself if I don't want to. And obviously, this is just a small example. You can add retries. You can add a lot of functionality there. This is what Spring Batch is for. You also have a support, Spring Batch admin. This is just a UI on top of Spring Batch. You have support for command line. Obviously, you have an API, and you also have a UI, so you can watch as a flow goes by. You can restart, abandon the jobs, figure out the status, and things like that. I know I'm rushing for this thing, and it's probably a very interesting topic. I know I'm interested about it. And the reason for that is because we're going to have an entire webinar dedicated to this particular topic. It's going to be held by my colleague, Mark, who's helping me with the questions here. It's called Data Access and Processing with Spring Data Hadoop Batch Integration. So we're going to talk not just about Hadoop, but Spring Data Batch Integration in general. It's scheduled for December 13th next month. So if you're interested in that, please watch the SpringSource website, and you'll see the notification there. And if you're interested, register. So I'd like to wrap everything up here because I'm 3 minutes late, unfortunately. Spring for Apache Hadoop is not the only effort happening at VMware. There's also Project Serengeti. It's an open source project that was launched this year in June, which basically it's about virtualizing Hadoop. So you have anything from just very easily provisioning and virtualizing Hadoop to things like high availability and different customization, quality of service, and things like that. So if that's something that you're interested in, do check out project-serengeti.org. You'll find a lot of materials, some nice demos, so you can get started with it in pretty much 5 to 10 minutes. That's it. Hopefully I didn't take too much of your time. These are the resources available. Again, Spring for Apache Hadoop, just like all the other Spring projects, is open source. The entire code, the documentation, the samples, everything that I showed is available for you to download under Apache License 2.0 on GitHub. So do check it out. Again, we're interested. We also have a forum where we're very keen in hearing from you. What are your needs? What are your questions? So do reach out to us. I know I spent more than 1 hour. So I'd like, first of all, to thank everyone here for joining this webinar. I'm going to take some questions now for 5 to 10 minutes, something like that. So if you do have any questions, I'll try to answer them. Let's see. Okay, a common question that we do get is whether we use certain distribution or whether we depend on certain version of Hadoop. For the most part, we don't. Currently, we test again and we compile against vanilla Apache Hadoop, so the one that you download from Apache. We support anything, I think, from 0.20 to 05 to 1.04. I think we also tested again 1.1.0, but it's safe to state that for sure in a couple of days. We also work actively with the various distros out there. We're actually part of the Green Plum distribution. We have an active engagement with Hortonworks and Cloudera as well. So whenever possible, we're trying to look at that. Also, we do a lot of testing against Amazon EMR, Elastic MapReduce. So we actually even have a section in our documentation for you to get started with that. So you can or look at that. So no, we don't. Also, what's interesting to point out is that we don't have any runtime footprint. So everything that I showed here is not going to interfere with the jobs, right? We do orchestration, but we do not alter your jobs. We do not modify our code. Basically, what we do is we instruct Hadoop what to do with their jobs and then send them out to you. But we don't modify in any way your jobs. So the jobs are the ones that you wrote. And that applies for Hive and everything else as well. Yes, it is also possible. There is this question here whether it's possible to add Hadoop jobs dynamically without stopping existing configured jobs. And yes, that's definitely the case. Again, everything inside Spring is API-based. So what you see there, the configuration is just a static component, which we read, execute, translate into API calls. It's the same with Hive, the job factory being a Hive template, pig template. You can do things programmatically, and that's the same thing with the job. You can actually literally, in 3 lines of code, you can say this is a jar for the factory, this is a jar, this is a configuration, whatever settings you want to, and then run it, right? And then you have a job configured from the factory bin. So definitely that's the case. And actually we encourage people to do that, especially when you're dealing with a big workflow, because you cannot foresee right away how your entire data pipeline is going to look like. Another question is whether we have support for our shell. Yes and no. We actually have a sample available. This is part of the effort that we have with the Concurrent, the guys behind Cascading. It's not really something that it needs supporting. We do integrate with it. What I mean by that is R in general is platform specific. It has some Java bindings, but they're not really used. So in our sample, we show how to actually just invoke that through the through Spring Batch directly, which is just execute a command line, which in this case happens to be R. You can see there that we do a bit of arrangement, such as passing arguments to R, but again, this is not something extraordinarily hard. And this falls down to what Hadoop is, right? It's an island. You have various things. Some of them are exposed in Java. Some of them are Hadoop specific, but the vast majority of it isn't. So you need this glue. You need to make things happen to go from one zone to the other. And we're trying to leverage that. So especially for components that are Hadoop specific, that's easy to do, but for the ones that aren't, especially with Spring and Spring integration tools like Spring Batch, you can make things happen without having to write a lot of code. There is this question here, Hadoop versus or similar to Camel. They're actually different. Camel maybe is more similar, or Apache Camel, I assume this is what you're referring to Spring integration, and that's an integration framework, which means it helps you, gives you the toolkit to provide, to create this integration problems. So you have different data sources that have to talk to each other. You have, as the data flows in, potentially do some analysis of it. That's basically it. So I think it's more of a comparison between Camel and Spring integration. In terms of Hadoop is really a batch analysis problem. So the two can work together. You can use integration, as I mentioned in my slide, with Hadoop, but Hadoop really is about dealing with big data, and Camel or any integration platform doesn't really supplement the batch analysis. Another question here is, do we need to push Spring-related jars files along with our code to HDFS? No, you don't. As I mentioned before, Spring for Apache Hadoop has no impact on your runtime. So basically using Spring for Apache Hadoop to configure your application. Once your application is configured, that's it, right? Because in the end, you have jobs written either in Hive or in Pig or just MapReduce, raw MapReduce, that are being shipped to the cluster. Now, Spring itself does the coordination, such as instructing how this configuration looks like, but in no way or in that point there is any coding there, because you do not depend on any Spring for Apache Hadoop classes, and thus there are no demands for that inside your cluster. Now, if you want to, sure, you can do that. But typically, no. As I mentioned, and as you've seen in the initial slides, when you're doing the WordCount, you use Spring literally to pick up a job that's already existing inside the Hadoop distribution, which obviously doesn't know about Spring for Apache Hadoop, and use Spring to instruct, to say, to tell the cluster, these are the jobs, these are the classes. Now, typically, you would have to write this by hand, so we still use configuration and all of that, and this is what Spring does for you. So it doesn't interfere, it has no footprint on the runtime. Again, everything is being decoupled. This is about configuring the cluster, not changing the job itself. Another question here is, can Spring Hadoop be implemented on an MVC layer when it's not set up as batch? So these are, I think, two things. First of all, Spring for Apache Hadoop and Hadoop itself, you use that to do batch analysis. If you want to use or you want to connect or expose this through a web UI, that's entirely possible. You can use Spring MVC or any other MVC or web UI framework. It's basically an architectural decision to decide how to do that. So for if you looked at the example that I mentioned, the Spring Batch admin is basically a UI based on Spring MVC for Spring Batch. But Spring Batch is not aware of that. Now, if you plug in Hadoop for your workflow in Spring Batch, obviously now you have a UI application talking to Spring Batch that orchestrates a Hadoop workflow. So it's entirely up to you. We don't have any requirements. Hadoop itself doesn't really have any. So sure, yeah, you can do that. But again, these two things are somewhat separate. So it's up to you to arrange them. This being said, Hadoop does have some UI in order to do clustering, to monitor how the cluster is doing, so potentially you can use that. Another question here, integration with HCatalog. Mark already answered that. That's something that we're keeping an eye on, but it's not something that we're actively pursuing. It's more sort of a metadata model between Hive and Pig. Obviously, there is demand for it, and once it's going to become a bit more mature, sure, we'll look at it. But it's, I think it's something that is closer, if you want, to the actual of passing data between Pig and Hive. So it's something that maybe belongs more to the user-defined function, meaning the script itself, rather than how you as a developer trigger that script execution. Let's see, and one more question, just to make a quarter after the hour. Going once, going twice. There's a question here. If there are any experiences for migrating from to Spring for Apache Hadoop from traditional shell scripting? And this is yes and no. Mark already replied. There are some companies out there that have already done that. One of them that we can mention is eHarmony. For the most part, we did, this is an active effort that we're pursuing to make sure that whatever you have available, whether we're talking about jar scripts to, jars and self-meaning tasks that are configured to actual scripts in whatever languages, whether it's Ruby or Python, are supported out of the box inside Spring for Apache Hadoop. For example, we've been through quite an interesting and engaging dialogue with the Harmony guys because they had a lot of jobs and they were putting all these jobs inside the application. And unfortunately, Hadoop tends to leak a lot of classes, meaning that whenever you run a job, right, from the command line, you start the job, you run the jar, and then that JVM, because this is what happens when you do it from the command line, shuts down. So obviously, this is quite expensive, but it means that if you have any leaks there because the JVM shuts down, you don't worry about them. So once we started migrating everything in, they discovered that there are a lot of leaks there. So we did a lot of tracing, and actually, I'm glad to say that due to their help as well, the Harmony guys, we had a lot of features or a lot of activity, a lot of code put in. We're actually looking at all the various leaks. This is similar to, if you're familiar to the anti-sort of leak prevention feature in Tomcat, where we know where the usual suspects are and we disable them, so there are no problems, which means now we can have a lot of jars, especially because this is a long-running app, and you can have multiple tasks, potentially the same task being loaded and is properly unloaded from the JVM. In some cases, even provided the feedback loop back to the Hadoop guys, so you can even see some issues in some cases, even with my name in, where we try to patch or address some of the leaks, and this is an ongoing effort, but for the most part, we addressed all this. Now actually, when you run a jar, there's not going to be any leaks. We make sure we prevent Hadoop for doing that. It's the same thing here with scripting. As much as possible, we're trying to look at the environment and make things happen. Currently, as far as we're aware, there are no blocks in migrating that, and obviously, maybe there are some bugs, hopefully not blocking, and that's why if you have any issues, if you have any questions, then please do reach out. That's something that we want to fix and want to make sure that you have a great experience. All right. I know there are some questions here, and unfortunately, I'm not able to answer to all of them. However, again, I'm looking forward for you guys to post on the forums or just reach out on Twitter. Again, this webinar is going to be posted, hopefully all the questions here as well, depending on whether YouTube is going to allow us or not. I'd like, again, to thank everyone here for joining me, for attending this webinar. Hopefully you're going to watch this space, Spring for Apache Hadoop, and also attend Mark's upcoming webinar on big data and Spring integration, Batch, Hadoop, and Spring. So again, thank you very much for attending, and hopefully you enjoyed it. Thank you.